Hey folks, welcome back to the shop. Frank here. Been a couple of projects that I've been postponing for the past couple of months as I've been working on the Cub Cadet Bush Hog. One of them has to do with the new Jet joiner planer that I purchased several months ago. There's a couple of videos on the channel describing the unboxing and setup and initial use of that machine. And one of the issues with it is, and it's not really an issue, it's just a characteristic of it, is that it has a European style safety guard over the cutter head, which is the style which slides in and out, and I'll show you what that looks like in a minute. Compared to the so-called pork chop style safety guard, which is used on many or most American made jointers. I'm more used to the pork chop style safety guard. The blade style safety guard on the Jet is a little less convenient and gets in your way when you're jointing and requires constant adjustment. And my Brutus coming in here. So this project I'm going to make or attempt to make a pork chop style safety guard for the Jet. It's a JPJ 12 jointer planer with a helical head. And let me get my little German Shepherd here. We'll go look at this and I'll show you what I mean. Alright, so this is the Jet JPJ 12. It's a 12-inch joiner planer. It has the European style safety guard. You set it to the width you need. Fasten this screw to hold it in position. Its height is adjustable with this knob here. You can raise it higher or lower depending on your need. And I will call this the European style safety guard because it seems to come on a lot of the European machines. This particular one, if you want to joint the face of a wide board, you have to pull this all the way out, and of course it sticks out. I guess at this point you just would remove it altogether. It's going to be in the way. But it requires constant adjustment based on what you're doing. There are people who have just taken them off and left them off. I'm not really comfortable doing that. If I'm going to joint a wide board, then clearly it's in the way here as you try to move past the joiner head. You're going to run into it because it sticks out. So that's what came on this machine, and many people use them and some people actually prefer them. So there's nothing wrong with it, it's just different. Now let me show you what the other style is. So this is my Delta 6-inch jointer, and it has what is often called a pork chop style cutter guard. It's spring loaded. It pivots out of the way as you push a board in to join it. It moves out of the way and then springs back. It's got a pretty lightweight spring, but it does return. So there's an advantage to that because it then keeps the cutter covered when not in use, and you're not constantly adjusting it. It's self-adjusting in that respect. Now, if you're joining a wide board, it does pivot out and kind of gets in the way. But being this is only a 6-inch joiner, it only sticks out about 6 inches. So it's not as big an issue. With a 12-inch joiner, if we make a scaled up version of this, it's going to stick out 12 inches. So that might create the same problem that the European style cutter guard creates, but at least this is self-adjusting for standard use, and you're not constantly changing the width of it since it's spring-loaded, and you could just push a board right through here and it goes back and covers the blade. So my plan is to make a cutter guard like this for that other machine. So let's get started. Alright, so before we cut it out of metal, let's do some CAD, some cardboard aided design. So I've made an approximate sketch of the scaled up by a factor of 2 pork chop cover, blade guard. So I thought before I cut it out, let's just kind of get a idea of what it might look like. It's kind of odd shape, but pretty similar to the, well, the real one's a little flatter here on top, but I think maybe we can fix that a little bit. Let's see. Maybe a little more like that. All right, so see what this looks like on the Jet. So clearly, if it pivots like that, it's going to stick out just as far. You know, most of your cuts are just going to be, you know, a couple inches, vast majority. I think this is where we'll start to see what this hole here. I need to, you know, create a pivot point and spring load it. It'd be cool if it was in sections and it collapsed as you did this, so that it didn't stick out a foot when you're all the way around here. Let me start with this. Here's my butchie boy. You being a good boy, huh? You being a good boy? Would you like your stomach rubbed? Would you like your tummy rubbed? To me, it's a little surprising that what to a lot of people would look like a big bad dog is so gentle, you know, but it's amazing. Where's my Brutus? Where's Brew? Don't call him, he said. I don't want Brew over here. I want all the attention. Brew, come here. Brew. Brutus. All right, Butchie boy. You're a good boy. Maybe we'll find Brew. Oh, there he is. Here he comes. Come here. Come here, Brew. Brew. He's gone over to his food. Come here. Come here, Brew. That's my good boy. There's my good Brew. Good boy. Yeah, you're my good boy. My good boy. Yeah. He's a little timid because he's got his bark collar on because he was making some racket. All right, so I have to also say that the intended use of this guard is that you would slide your wood underneath it. So if you're face joining a wide board, you don't have to move this out of the way. And matter of fact, they don't want you to. They want you to leave it here, or most people would say it should be left there. As you push a piece of wood through, you move your hand over and then, push it through, pushing your hands over it. In that case, you never expose the cutter head at all. To me, it's a little difficult to maintain an even movement of the wood. If you stop the wood as you're moving it through, you'll get a little ridge on the bottom edge where you stop from the cutter head. So when you're joining the face of a board or edge of a board, doesn't matter, you want a single continuous movement all the way through. You don't want to stop part way, because then you get a little inconsistency in the finish. And for me, that's pretty difficult to do with this type of a cutter guard. With the pork chop cutter guard, with this, you push something through and you just keep going right through, and then it pivots back when you're done. So that's the advantage of the pork chop style versus the American versus European style. The people that are used to this, I'm sure, are screaming in the comments that no, you shouldn't do that, this is safer. I don't know. Whatever works for you, I think, is what's safer. Something is uncomfortable or cumbersome, I don't think it's safe. With continuous use, repeated use, I'm sure I would get better using this type of a guard. And who knows, I may switch back to it. Whatever I do in terms of creating a pork chop style guard, I will make it be removable. I'll retain the ability to use this. So, I will have the choice. And I don't know which I will prefer. I may decide that this is long-term, this is better. Until I use them both, I probably won't be able to make a decision. And of course, just in case you're wondering, the pork chop blade guard is not going to be just a single flat sheet. It will have about a 3/4 inch rim around it. So it'll be raised up. You know, something like this. And it will be designed to make sure it never contacts the cutter head during any of its travel or use. So while what you're going to see me work with is a flat piece of steel, you know, recognize that as I work on it, I will then add 3/4 inch, probably 3/4 inch rim, you know, around at least most of it. Maybe not over here, don't need it, but certainly this section. So, okay, just wanted to clarify that so you see what my train of thought is, since that's kind of what this video is all about, my thought processes. All right, so let's take a picture of this. All right, so here we are in Fusion 360. Going to insert a canvas, which is just a bitmap image. And I'm going to go to my SD card where I just took some pictures. Where I think I just took some pictures. Here we go. Let's see, take the most recent one. Got to pick a plane to place it on. Okay, so there's our photograph. So we're going to basically trace this photograph. And we can scale it to any size we want. I'm going to leave it at this size right now to work from. Now, in order to trace an image that you've imported, we go to create a sketch, and we're going to sketch it on the XY axis. Now you see the size of this image. Here's the scale. It's only like 3 inches by 2 inches. Doesn't matter. We're going to sketch it at this dimension, and then we'll scale it up to whatever size we need it. So the way to trace something in Fusion 360 is to create a fit point spline, which is basically allows us to select points and approximate the perimeter of our object. Now I'm going to zoom out and back in to get. This is not an exact. You can get more exact if you zoom way in and are more careful in the placement of your points. You can get, you know, a very accurate copy of whatever you want to duplicate. But here, you know, the exact curvature, you know, of everything is not that critical. But like you said, I mean, you can zoom in, controlling the spline dimensions can be a little fussy, but generally it's pretty easy. For a simple object like this, it's very quick and easy to duplicate. Corners, you have to be careful going around a corner so you don't create a discontinuity or a funny shape. Now there's no reason you couldn't create straight lines and specific arcs of a certain dimension. You can go in and create an arc or part of a circle or something, and, you know, add that to the diagram so it connects a couple of these points so that you can close the loop. So there are ways to create other line segments other than using the fit point spline, because you can combine it with straight lines and circles or whatever else you want to do. So if you had an object that had circles in the middle of it, you could draw the circles separately. And you would just go create circle, rectangle, line, polygon, or use the tools across the top here. So I've created a closed shape, and I can, over here on the left, I can turn the canvas off so that all I have is the closed shape I've created. I can select this shape, hitting press pull. I can extrude it. I'm going to extrude it backwards. I'm just going to do 1/8 of an inch, so minus 0.125. So now I've got the sketch turned into a body, and you can see it has a little bit of thickness. It's not perfect, but it's pretty close rendition of the piece of cardboard that I took a picture of. So now that we've basically finished designing it, we want to create the G-code to cut it out on the plasma table. So we go from design into manufacture. We create a setup, and the only thing we really need to do in the setup here is select no additional stock. So since we're cutting through it, go up to the cutting tool and create a 2D profile. Here we need to select the tool we're going to use. In my local library, I have my Crossfire Pro plasma cutter tool. Basically, it gives criteria for the tool. The nozzle's 1 inch in diameter, the kerf width is 60 thou, head clearance 40 thou. It's a plasma cutter in inches. So since that tool was set up to cut 1/8 of an inch, well, actually it was set up to cut 1/4 inch since it's 40 inches per minute. So I'm cutting 16 gauge, so I cut that at 120 inches a minute, and I need to select the profile. So this is just basically selects this face, and it creates a tool path. So this is the tool path. This gray area is the clearance for the nozzle, and here is the entry and exit points. So if we want to model this and go through a simulation, and that's pretty fast, maybe we slow it down a little bit here. So it's basically going to enter over here, cut around, and be done. So that's fine. You may want to run a simulation if you have a complex shape to make sure all your holes are, are cut out, that everything you want cut gets cut. Go up here. Now I'm going to call this my pork chop model. And since this is 16 gauge pierce delay 0.55, you normally have to change that depending on the thickness of your metal. And that's it. So that's already set. We can post that code. So this is going to be called my pork chop model. Once I've posted my G-code, I can go over to Fire Control, open my pork chop model. So here we are with the diagram now. It is, you can see the height and width are pretty small here, 4.93 and 4.39. The actual height is 15 inches. So let me scale that. 14.39, so 15 divided by 4.39 equals 3.46, or basically 3.5. We're going to do 3.5, generate. So this creates a larger version of it. The height is now 15 1/4 almost with the 17, so that's pretty close. All right, so that's the pork chop that we cut out of cardboard and turned into G-code instructions for the plasma table. Most of my videos I start with the table already full of water and everything ready to go. Since I had just cleaned the table out after my last project, I thought I would just show you what it looks like. There's one of the 2 drains here. It has a gasket. It's a bar sink drain basically. There's another one over here. And so those drain into a 20-gallon storage tank. And then there's a pump on the tank which then pumps the water back up to the table through this little brass copper spigot arrangement. So I'm going to fill the table. I have a switch here. And it pumps water up into the table. So for those that have been wondering what this is in the table, it is just water with an additive called Plasma Green 1050, and it's an anti-corrosion, anti-biologic additive that is made for plasma tables, and it prevents rusting of the slats and your work pieces. So that's a concentrate which is added to the water in a 5% ratio, so 20-to-1 dilution. The table holds about 15 gallons, so there's almost a gallon of the additive in there. All right, so we'll let this table fill up and we'll come back. So this is the scaled up from the 4-inch item that I traced in Fusion 360, and the one thing you got to be aware of, if you scale up, it also scales up your entry and exit lengths. Normally the entry length is, you know, 1/10 of an inch or something, or 1/4 of an inch. So here it's about 1/2 an inch on each side. So anyway, so there's our pork chop, and let's go compare it to the piece of cardboard, see if we're even close. Okay, setting it here on the table. I mean, it's pretty close. Facsimile, it's a little bit off. I mean, probably due to the angle of the camera distorting the image, since I wasn't directly. I probably should have put it on the floor, gotten as far back as I could, but it's close enough. So I think pivoting it here like this will work. I've got the cutout here. I've got it on a piece of plywood just so it doesn't damage the cutter head. Don't risk damaging the cutter head. So we need to make a pivot point here, and I think I'm just going to mock something up. Need a strip of metal. I'm going to try to use these 2 screw holes here. So it will, you know, pivot something like that. So I probably want to strip about Give myself plenty of room. Nine inches long and 3.5. Let's make it 4 inches. So we'll make it kind of a triangle here. 9 inches, 4 inches, and whatever the resulting piece is. So let's cut out that, and that'll be our base that we'll make the pivot for. So we're back in Fusion 360. Let's do a new design. We said we really just needed this triangle shaped piece. So we're going to create a sketch. I'll always pick the front face. Gives us the XY coordinates. And I'm going to just draw the triangle. We said 4 inches by 9 inches, and so we hit letter L, and I'm going to hit X so that it is a construction line. So we're going to go up here 4 inches, type in 4 in the data field, and that gives me a length. And then I'm going to draw another line from this point over 9 inches and hit enter. And then I'm going to connect these two corners, 2 points. So this is my triangle, but of course I don't want the, I don't want a point here, right? So let's Control Z, let's just delete that. Let's come down, an inch, 1 inch. There we go. And then from this point, come down to, let me come over from here. From this point, let's come over 2 inches. And I'm just making up these dimensions because they just seem reasonable. And then from here up to this point. So I've created this perimeter. I can select each of these segments and then hit X, and that changes them from a construction line into a actual line. So there's my triangle of sorts. So don't want these sharp corners, so we go up here to the fillet tool, and let's create a little radius like 1/4 inch radius. That's pretty good. Let's zoom in on that, select it, turn it into a line. There we go. And we'll zoom into each of these areas here. We have to go back and select that tool again. And this is a 1/2 inch. I like the smaller radius. So we'll do that. And we can even fillet these two, and we want a big radius there, maybe a 1 inch. So we just want a smooth curve there. Right. Zoom in over here, go back and pick the tool. There's probably a way to retain the tool. Sometimes the tool gets sticky and you can use it more than once, but I just tend to go to the tool each time. And I'm just doing 1/4 inch on all these. And of course, since I'm still in construction line mode, over here in the sketch palette, line type, it shows construction as opposed to not construction, so to a regular line. But I can pick this segment, turns blue, hit X, turns it into a line. So then there's my triangle, and I'm not going to, well, I should pick the centers for the fasteners. So let me go back and measure those, then we'll come back here and put them on the drawing. Okay, I decided not to try to cut the holes here in Fusion 360. The issue with it is if you cut the holes out with a plasma torch, the edges of the holes get very hard. Basically, they're tempered because you get water splashed on them. You get them red hot and you get water splashed on them, so they harden, and then you can't drill them. It just becomes a machining issue. So rather than having to deal with that, I'm going to just go ahead and cut this out as it is, and then we'll drill the holes later. Okay, so I've got my initial shape. Again, I'm going to extrude it, which is press pull. You select the object. I'm going to go minus 0.125 again. Just I'm not going to make it 1/8 of an inch thick. I'm not cutting out of 1/8 inch material. I'm cutting it out of basically 60 mils, 60 thou. So it's almost a 1/16 of an inch. I think it's 16 gauge. So I've got the object here in my design. I go to my manufacturer tab, and this is the same as every other time. You do a setup at first. It's cutting. Where you pick the origin here doesn't really matter. You just don't want to have any additional stock. So then we go to, let's save that. We did that. Okay. We'll go to the cutting, create a 3D profile, and we need to select the tool again. Every time you create a new design, you got to go select the tool, and the tool defaults to 40 inches a minute in this version of the tool. We're going to cut it at 120 inches a minute. It is a through cut. Now under the geometry tab, we pick the profile, which is a face contour. We just click OK, and there it creates the tool path. Post the code. We're going to call it pork, if I can type, pork chop pivot bracket, and the pierce delay of 0.55. You can't go less than 0.5. You would probably be fine with less than 0.5 on this material, but the machine won't let you go less than 0.5. Okay. So we're going to post that code, jump over to fire control, pull in our pivot bracket, so there it is. I'll set up the plasma table, find a location that's appropriate for cutting this out on the sheet that we've got on the table, and we'll come back with some plasma cutting. Probably not the most efficient use of the space, but worked. All right, so here's my little triangle. It'll fasten like that. We'll establish a pivot point. About right there. All right, so we'll take some dimensions on these holes. Transfer them to this bracket. It pretty much sits flush with the table, so I guess it depends on the table height, right? All right, on the DRO, we'll move 5 5/8, 5.625. And from 3/4 to 1 1/8. So what is that? That's 3/8, 0.375. Put that same countersink in this other hole. A little difficult holding this piece of sheet metal. I'm sure there's a better way of doing it, but this is working. Okay, that's pretty good. All right, so let's go see if this fits. All right, looks like we got a good fit here. And not quite flush, but pretty close. It shouldn't be an issue. The material's pretty thin, so. All right, so that looks good. We'll build off of this, create our pivot point here. So next step is to clean this piece up. Still got some slag on it. Let's clean that off. And we'll pick a point for our pivot. I want a nice accurate 1/2 inch hole here. So fixturing this plate on the mill, it wouldn't fit in any vices or anything. I'd have to clamp it to the table, risk drilling into the table, not worth it. So can't take the work to the mill, bring the mill to the work. This is my magnetic drill. It's got a 1/2 inch bit in it. All right, so that didn't work, and it didn't work because the metal is only 1/8 of an inch thick and doesn't have enough magnetic force to hold. So in that case, you have to go very slowly until you establish a concentric circle that will hold the bit in place. All right, so but it does make a beautiful hole. It's almost like drilling it with a mill. So that's good. So we're going to weld a 1/2 inch pin in here. That'll be our pivot. All right, folks, I'm going to wrap up this part 1 video now, and we'll come back next time continuing to work on the pork chop cutter guard. And as I said earlier, don't know which one I'm going to ultimately prefer. I'm going to try the pork chop style out, see what I think about it. As I said, you know, there are going to be people who will swear by this European style for this type of application, but the pork chop style has been used for decades on all sorts of joiners, wide joiners. So I'm going to see which one I prefer, and I'm going to make it removable so I can use either one. All right, so we'll come back next time, continuing to work on this. Leave me a comment, tell me what you think about it. Which one would you think you would prefer? And especially if you've got or have used a wide joiner like 10, 12, 16-inch joiner, the type of blade guard you had, if it even had a blade guard. Some of the old ones didn't even have blade guards. And let me know what your thoughts are on it. And we'll see you next time.